Hey everybody, this is Larry. This is day 7 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, and join me on Discord, and let's get started in today's problem. Vertical order traversal of a binary tree. Given a binary tree, return the vertical order traversal of its node value. Okay. So 3 and 15 is that, 3 and 15 is the same level? Okay. How do I want to do this? There are a couple of ways to do it. I mean, they're all going to be recursion in some way. I mean, I guess you could do things on the queue as well. But yeah, I think actually maybe I would do that. I think generally I would just do it with a recursion, like if it was a contest, just because it's really quick. You have a list of lookup values or something like that, and then that's it. And here I'm going to do the same thing but with a queue. Yeah. No, 5 comes first because 5 is smaller. Oh wait. Let's see. If two nodes have the same position and the value of the node is that is reported versus the value that is smaller. Okay, so maybe I do have to think about, because that is a little bit of an edge case. But yeah, but I think conceptually this is not that hard. But there may be some edge cases that I have to think about. And they even tell you really how to go about it. The only thing tricky is about the same position place, which is here 5 and 6. What is a good way to do that? I mean, so there are a couple of ways that I'm thinking about now. One of them is just going through the thing and then sort later, and then the other one, but the thing that I was trying to think about is just trying to do it live, which I mean, I guess you could do it with like a multi-set, like a tree set type thing, depending on your language, or tree map or tree multi-set maybe. But I think all of that is just will give you a better complexity. But I'm just going to do a lot of sorting. I think that's where my head's at. And with that, maybe I won't do it with a queue. I would just do it. I think I'm just going to do depth first search, generate all the coordinates, sort, and then bucket them together. I think that makes it more straightforward to just get it right. So yeah. So now let's just do I guess in order. Post order doesn't really matter as long as it's recursive. And then we have a list of oops. And then we have to group by some stuff. Okay. So yeah, so if node is none, return, and we actually want to keep an xy value. Otherwise, inside append xy node. Well, it's by height, so we or by column. So we actually want to do y first. Oh wait, which one is x? Which one's y? Well, we don't have to use their definition in that case. So we'll keep track of it this way, and then on the left node, we want to do. Also, this is not in order anymore. I just do pre-order. Let's just call it pre-order. Oops. Node dot left, and then was it x minus 1, y plus 1, pre-order node dot right, x plus 1, y plus 1, right? Why does this go down? I don't know why they do it that way, but this notation is a little bit weird, but maybe not. Yeah, and then now we just have to bucket by. So now we want to sort. How do we sort it, right? Well, first of all, we could just do a sort, and then now we want to do group. We want to, and we don't even have to do it this way, per se. Yeah, I mean, there are a lot of ways to do it. That's why I'm thinking about which way is the easiest to explain. But I'll just have a lookup table. So yeah, so we'll just have a hash table. Hash is, and then now for col, which is x, y, node in hash in answer. What do we do? Well, we do something like this, that append no y and the node. So that's the height, because we want to go from top to bottom, I believe. Yeah. Right. Yeah, from top to bottom. So that's how we'll do it. And then here we'll just, yeah. And usually I would use a default list, but I just want it to be a little bit clear. In hash table, x is equal to a list. Okay. And then now we can just, well, for x in hash table dot keys, we sort it. Let's sort. Actually, maybe here we want to actually do the value instead of the node, because that's okay. We sort. So that would give us the smaller y first, and then tiebreak by the value when they have the same. And then now we just have to put it back to the return results. I guess I could actually just do it here. So we sort it, and then now for table x, so we have the y column and then the value for, we just do the right. And then we append a list version of this. And I think this should be okay, maybe, hopefully, we'll see. But yeah, I think logistically this is okay. This is just, should be straightforward, but of course, I didn't call the pre-order at all, that's why. So we want to pre-order and 0, 0. I always forget that, but it's easy to fix. Okay, well this seems mostly right. I mean, the things are happening in the same place, but they're obviously not sorted correctly. I misunderstood it. I think I misunderstood some as part of this problem, to be honest. No, we go 4, so why is that? This should be on x is equal to 0. Maybe the keys are not sorted, so let's okay, so yeah, just the keys were not sorted. So now let's try an empty array, just because of one item. Minimal test cases there I would probably do some on performance, but it should be okay. Looks good. Let's submit. Yeah, I wonder if there's a live version of this, but for the most part, it should be okay. I think this only has. Can you prove that this only has 2 keys? Because one is coming from the left and the other one's coming from the right, or does it I don't know actually. But in either case, so the pre-processing step is going to be linear and linear space. And for n is equal to 1,000, that's way more than better than enough. The only thing that's a little bit uncertain is the sorting, and at the worst case, it's just going to be sort the entire thing. So it's just going to be n log n, though you could probably do some tighter bound if you do the math. But yeah, little bit annoying, but seems okay. It just depends on how you want to do it. So let me know how you did it. Let me know what you think. Hit the like button, hit the subscribe button, and I'll see you tomorrow. Bye bye.